What do you get if you take 40 experimenters, they're 12 experiments, put them in an aircraft, accelerate at maximum thrust, 50 degrees up into the air, and then let go? You get zero gravity science. And that's exactly what we're doing here on the European Space Agency's 70-second parabolic flight campaign. My name's Neil Melville, and I'm floating all the way up there. We've been preparing for this for about a year, and now finally we're falling out the sky over Bordeaux. Each parabola gives us about 20 seconds of weightlessness, and we have 31 parabolas in total, so 10 minutes of weightlessness for the whole flight. The price we pay for this is 20 seconds of double gravity before and after each parabola, which is what's happening just now. So now I'm in double gravity, twice my normal weight, so is everything else in the plane. Any European scientist can apply for these campaigns, and we select on the basis of scientific merit. We have a hugely diverse range of experiments here, from human physiology, metallurgy, electronics, cooling, even astronomy. The advantage of parabolic flight compared to our other microgravity platforms is that here the scientists get to fly with their own experiments. This means that they can see what's happening and adapt on the fly. They can change their parameters, they can change the samples. For the human physiology experiments, they can change their test subjects. Of course, this wouldn't be possible if the experiments had to be miniaturized and controlled by remote, such as on a sounding rocket or robotic capsule. And on the International Space Station, the astronauts do a great job for us, of course, but they can't make the scientific decisions that we can make here. This repetition and this accessibility makes this platform very unique and very special. So this experiment is called Progra 2, and they're looking at micrometer-sized particles creating clouds of dust and scattering light through them. The dust is simulating dust that we find in our solar system and in other places in the universe. The point is to find out how that light scatters and record it very carefully so that we can then make more sense about astronomical observations in the future. Healthcare management will be an increasingly important part of long-term human space exploration. We need to develop tools, models, and countermeasures, for example, for healing chronic wounds. This experiment is looking at absorption phenomena in biomimetic tissues, repeatedly loading and unloading those tissues in zero gravity and seeing how their absorption properties change. This simulates the effects of weightlessness and astronauts moving during spaceflight. The knowledge gained from this experiment will pave the way for new biophysical models and countermeasures to be used in the future. This is the VIPGRAN experiment. They're looking at granular material and seeing how this situation evolves in zero gravity. In particular, I'm trying to understand the underlying physics in detail. For this flight, they're investigating the behavior of particles as they change from a gas-type situation into a clustered-type situation. Think about a sandstorm, for example. If you'd like to know more, as always, please check ESA.int. Just in time.